Furitek. This is the Stinger brushless system. We're going to throw this in a build to show you what it's about. Let's go ahead and open these guys up. Here's the ESC with the Bluetooth. And here's the micro Komodo with the mount. Now remember, this is the Lizard Pro versus the regular Lizard. The Lizard Pro is a 5 or 6.5 volt, 2.5 amp BEC, which you can change via the app, whereas the regular Lizard is a 5.5 volt, 1.5 amp built-in BEC, and you can't change it. Also, this lets you run 3S. This also has a constant current of 30 amps and a burst of 50, whereas the regular Lizard has a 20 amp constant current and a 40 amp burst. Basically, you almost always want to go with the Pro, the BEC, so that you can run, you know, higher end servos is kind of a must. Also, it's always nice to be able to run 3S. You can just, yeah, it's worth it. So because we did not get the Stellar with transmission, we're having to use one of our transmissions, and you've got to take out the original motor plate and put in their adapter here. I would recommend, if you're going to get one and you don't already have a transmission you want to use, just get the one that comes with the transmission. It'll make your life easier for sure. Okay, we've got our motor on our motor mount and our motor mount on our transmission. One thing we have left to do is to get our mesh set right. And when you're doing this, you have to be careful because this screw, your motor mount screw, can actually hit on your main spur gear here. So if you see how I've got this, if you turn this way too much, if you turn the motor this way, your screw is actually hitting on the spur gear, this screw here. So you have to make sure you turn it more like this, and then you can slide your motor closer to the spur. And remember, there should always be a little bit of play between your pinion and your spur. That's a good mesh. It's hard to do meshes in these because you don't have direct access to the pinion and spur, so you can't really do the paper method very easily. But you can hold the motor, and you can move the transmission here, and you can see how much play is between the spur and the pinion. And so you can adjust it just kind of visually and by feel. You can also hold this and try to turn the motor just a little bit, and you'll see a little bit of play in there. Okay, and remember, as you tighten this down, it could adjust the spacing. So just be careful as you tighten down that the thing's not moving, the motor or the transmission or the mounting plate isn't moving too much. And just slowly tighten it down and feel your spacing. So we got a little too much space there. We'll tighten it back down. You can see the pinion and the spur just kind of barely moves. It's not gonna, it's tight enough to where it won't strip, but it's also not over tight so that you don't burn up your motor or cause unneeded wear and tear. And then you can go ahead and tighten down some more and check again. You can kind of see it moving in there just a tad. And that should give us a nice smooth operation here. All right. So this is the chassis we're going to put this guy in. Let's go ahead and get our transmission mounted and our motor mounted on our skid. We'll figure out which direction we want it to face. So we're going to go ahead and forward mount the Furitek Komodo setup, the Stinger setup, if you will. Kind of forward mounted. We'll probably do something like this with our ESC and our receiver. Maybe like so, or maybe we'll just mount. We'll be able to mount this potentially. Well, I don't know. Maybe we can mount this under here with it. If we desolder these, we'll have a lot more space and we can actually just mount it like that. Because remember, you're bypassing your battery and your motor. Your battery and motor plug into the ESC. If you're using your stock receiver, ESC combo, maybe your ESC side of your version 1 burned out, and so you got your external ESC, you can actually remove all this. You can remove the switch, you can remove both the power and the motor, and that gives you a much flatter board, and you can mount stuff on top of it. So I think that's probably what we're going to end up doing here. It just kind of makes sense, especially if we're going to try to mount this here. That gives us the ability to mount this here, and then mount our Lizard Pro right inside of here with it. And it'll all go underneath and fit nice and snug in here. All right, so I think we're going to try that. Now, before we desolder this and start doing stuff to it, we just hooked everything up. We want to make sure everything's working on our stock remote. So essentially, you power. We use the red JSTs, so we kind of forced it in there. Well, obviously that's not going to be there permanently. We're going to switch this to a JST at some point. But essentially, this is your motor plug, this is your power, and then your servo wire, that looks like a servo wire, goes into your channel 2, and then your regular steering servo goes into your channel 1 like it always has. You just bind it up, and you should be good to go. So that's using our stock version 1 electronics. And we'll be able to adjust stuff on the app and all that once we get it all installed and get the rig set up. But yeah. Seems like it's going to be a good time. Alright, so we can go ahead and, I don't know if we're going to remove the switch, maybe we will, but we're definitely going to remove the power and the motor on these, because we're not going to use it. I don't think these are actually fried, so we're going to try to keep these. That way, if we have to, we can put it back together if we're going to put it back to stock configuration or something weird like that, but probably not. But we're going to keep this stuff. We always like to keep our little parts. You never know when you need them. And see, your switch, your power switch no longer works on this, so maybe we will still take that off. We usually solder them on the on position anyway, so even if we went back to stock, we'd be always on, because we never leave our stuff plugged in. We always just use the battery as our power switch. We never leave our batteries in our rigs. Just kind of a safety thing, and I think good habit. So everything's always on. If I had the option, this would be soldered always on. We might do that at some point. I don't know. Right now, I don't want to mess with it, though. So we're just going to switch this to our JST and remove these.
A few moments later.
Okay, you can see we went and desoldered our power on our motor. Now we've got this nice space here, so we can mount our ESC nice and flat on this board, essentially, and fit it in there, and everything's still working as well. Servo and motor. We always like to test along the way. So one thing we like to do when we're having a decased ESC or any decased electronics is we will conformal coat it, which is covering it in this acrylic coating that basically waterproofs it, and it also prevents electrical current from jumping. And just so you know, carbon fiber can conduct electricity. So if we were to take this board and just mount it straight to the carbon fiber with nothing between the carbon fiber and the board, there's potential that some of these spots could arc and conduct electricity between the different chips and fry things. So one thing we like to do is make sure that there are no solder points that are really tall. There were some here, but that was the power switch, so we went and removed that because we're not going to use it anyway. And some of these solder points here, they're pretty long. The wires stick through the board, and then they basically extend pretty far out behind the board. So to help get us the board lower and to prevent them from scratching into the carbon fiber and arcing, we'll snip them off. Now be careful if you're snipping stuff on a board, you don't accidentally snip a tiny chip. That'll ruin your board for sure. But some of this stuff, like this one right here, you can see it. We'll just go ahead and kind of clip it and get it so it's a little less pokey, essentially. You just don't want it to be able to scrape into the carbon fiber. Even if you conformal coat it, the conformal coating can chip off and touch the carbon fiber, and you could have issues there. I've never had issues, but there's always the potential. We conformal coat it, and then we usually mount it with hot glue, so the hot glue is also between there, or if you have double-sided tape or whatever, that'll help prevent it from touching the carbon fiber. But just know, carbon fiber can conduct, so we like to conformal coat anyway, just so that there's not exposed electronics, you know, and it helps waterproof it. So when you're conformal coating, just make sure you don't get it on any of your, you know, plugs, because it'll stop the signal, essentially. So conformal coat the antenna here, you can do that, and anywhere where you're not plugging things in. And if you had the switch still on there, just be sure that your switch is in the on position. That way, if you conformal coating gets down in the switch and it gets stuck, which I have had happen before, it's stuck in the on position anyway. Or just be very, very careful, but I'd still recommend keeping it in the on position just in case. Sometimes you can break them loose, and sometimes even if you do break them loose, like break the on and off switch loose, still there's conformal coating over the contacts, and it does not work. So we just like to have them on the on position. And usually we'll do 2 coats, and you don't want to get too crazy with it, just enough to cover it so it gets in the cracks and crevices and the edge of the board. And then we usually let it dry and then do one more coat. So we're going to go ahead and do that, and we'll come back to installing the boards into the chassis.
More moments later.
Our board's all conformal coated. Planning on going something like this. And as I mentioned before, we like hot glue. It's easy to peel off if we don't want to put our board there anymore or we want to move it. And it seems to hold fairly well, so we'll just go ahead and kind of load this up right here. And it's actually pretty easy to clean up, so if you get it kind of where you don't want it and whatnot, you can clean it up fairly well. And if you've got multiple temperatures on your gun, when you're doing boards, I usually like to do it on a lower temperature, not super hot, especially if you have conformal coating on it, because you don't want it to like damage the conformal coating or get the board too hot. If you're doing it on Lexan and plastic, you definitely want to use it on low. Also, it's just kind of easier to work with. Well, it's more sticky on low, but if it's on hot, you'll burn yourself. So just gotta be careful. You can still burn yourself on low, but the hot's on this one's pretty hot. All right, so I'm going to try to tuck this in here like so. We might actually not even need to hot glue this because I think there's going to be so much pressure on it. Let's see if we can tuck it in like that. And this bar is going to hold this in. I mean, there's a lot of pressure on there. We don't need to hot glue it, especially when there's hot glue already holding the board on and putting some thickness in there. Yeah, it's not going anywhere. All right, let us get that in there and then we'll come back.
A little longer than a few minutes later.
Okay, we're all installed. Just double check, make sure everything's still working. Sounds good so far. Steering, throttle. Seems all right. Let me go ahead and show you what we're working with here. So we've tucked it all in there. You can see we got a little bit of hot glue just to keep it, put some padding in there really, tighten it up, make sure it doesn't slide anywhere. And then the Lizard Pro is actually just sitting on top, and then we even kind of tucked in the Bluetooth module, which we can pull out. It's in there pretty good, but it's not permanent at all. So the Lizard Pro and the Bluetooth aren't permanently in there. All of our wires are nice and tucked. And yeah, I think this is going to work really well. We think it looks pretty good. We can always run our motor wires over the top of the servos just to make sure they get held up so they're not hitting on any of the moving parts. So we may end up doing that, throwing the motor wires on top. Shouldn't matter too much. Might even be able to just pull them through here. Actually. Yeah. That way they're just on top of the transmission versus being down where it could hit on our drive shaft or whatnot. Yeah. All right, so we've got the app set up, Bluetooth plugged in. All you got to do is select your car when your Bluetooth is on your phone and the car is on. Sometimes it'll ask for a password. The password is probably 1234, or it could be all zeros. I don't remember. You're able to change your Bluetooth name and reset your factory name and all that stuff. You can also change your password and update your firmware. Make sure you're on the most recent update for the app and the firmware. We have not updated our firmware yet, but you can see the firmware log here. Fixed bug, max throttle, and bug on brushed. Increased FOC startup, field of control startup. Fix the bug on max throttle. So we are currently on 2.3. We want to be on 2.6. So let's go ahead and do that. All right, so that was obviously sped up, but it took less than a minute. You can now see our firmware is 2.6. The firmware version available is a 2.6, and we're good to go there. Our motor type is brushless. You can choose brushed or brushless. And then the motor, if you're running a Furitek motor, we're running the Micro Komodo, so we'll change that. Auto sleep, you can have the car automatically go to sleep after 30 minutes, 10 minutes, 5 minutes, 3 minutes, 1 minute. Okay, we're not going to do that. And then you can change the temperature from Fahrenheit to Celsius and back. All right, so those are the basic settings of the app and the motor. Those are all right here. This again shows us our device name. the kind, hardware, firmware, and we can disconnect. And then here's our main menu. First thing is telemetry. Telemetry is basically your throttle curve. You can change all this stuff. Okay, not in here, but you can. You can see here you've got your throttle curve. It shows your throttle on your remote, and then your RPMs. Also shows your voltage, amps, which is not showing anything right now, and then your temperature. And then this is your logging. If you keep swiping over all the way to the end, that's your logging. Your RPM and throttle. Red is RPM, blue is throttle. Okay. And then your reverse curve. All right, so running settings. The first thing here is forward with brake. Then you have forward reverse with brake and forward reverse. So as a crawler, you're going to usually use forward and reverse. That means as soon as you hit forward, you go forward, and then as soon as you hit reverse, you go reverse. Forward with reverse brake is basically you go forward, and then that is brake. No reverse until you let off, and then you get reverse. You'll use that probably on monster trucks or any kind of road car, because you don't want to just go immediately reverse if you're going fast. You'll break stuff or flip over, or things of that nature. So that gives us brake, and then reverse. And then forward with brake is generally for race cars only. Forward, brake, and you have no reverse. And a lot of times you don't want reverse in a race car, or they won't let you use reverse in a race car because if you wreck, they don't want you backing into traffic and people hitting you. All right, your voltage cutoff, you want it at least at 3.2. We usually do 3.4 or 3.3 just to be safe. This is where your servo will continue to work, but your motor will no longer run if your battery voltage goes below 3.2, 3.3, whatever you set it to, volts per cell. And that's because you don't want your LiPo to ever go below like 3.2. It will permanently damage it if you go too low. Our servo voltage output is, how much voltage goes to the servo. Obviously, for just a stock servo, you're going to use the 5 volts. If you have a higher end servo that needs more power, you can go to 6.5. This is a big reason to get the Pro. Rotation, obviously, that's going to change the direction your motor's going. So if you're going backwards after you install, just switch that. Normal startup power. That's how much power's going to the motor right off the bat, I believe. We're not 100% on that. But you can see my very low has quite a bit of power going to it. Not necessarily high RPMs, but it seems like it's got a lot of juice going on there. If we lower it, you can see it's going a lot slower. Okay. I don't really see a huge difference there. If somebody knows what startup power is in a better definition, put it in the comments below. And then you guys can check out the comments and see if somebody else knows better than I what startup power is. Some of these I'm just not going to know, but I'll try to give you my best explanation and I'll show you. So let's see here. Startup power seems fine. Okay, and we'll go down very high. I don't know, I don't see a difference. We'll leave it on normal. Your max forward is obviously your max throttle forward. So you can increase that. We want that at 100. We usually set our max reverse to 50%, so we don't have quite as much speed in reverse. Your max brake, that's only going to work if you're using reverse with brake, but basically that's how much it will brake when you use brake, obviously. Drag brake is how much it drags when you let off the throttle. Now that's with brake. I don't think it works when you have... oh, it does work. Okay, so just forward and reverse, you can see when I let go, it just stops. If we turn down drag brake to 0, if all the way out hit reverse, there you go. We probably need to calibrate. Let's do that real quick. All right, so calibrate is under throttle, and you should really do this first. It's going to say, do you want to start? You say yes. It's going to beep, and it's going to ask 0 speed. That basically means have your throttle set at 0. You can see when I throttle. Okay, make sure you're set to 0. Say OK. Then you're going to max. You're basically going to give it full throttle. Say OK. And then you're going to brake. And you're going to say OK. And this is basically to help make sure that the ESC understands all the positions of your transmitter. Now it says we're at -2. Let's turn it off. Turn it back on. Maybe we need to turn this guy off. Turn it back on. Hopefully we'll be at 0. Always click that. There we go. It says we're at -2 still. Oh, there we go. All right. So, in my experience, it's usually always been 0, 1, -1. It's, especially with these remotes, they're not the most precise. If you're using a higher end transmitter, like a Noble or something along those lines, you're probably not going to have it vary. So -1. But it's not a huge deal as long as, for the most part, you're at 0, 1, -1, somewhere in there. All right, let's go back to our running. So we were looking at drag brake here. So drag brake is supposed to be, when you let off the throttle, how much resistance the motor puts on the wheels or the drivetrain. And this like has a drag brake of 0. When I let off, it just stops. And you can see sometimes it just continues to have like a fake roll. I don't know what that's about. See that? And sometimes it just stops. I don't know what's going on there. I have noticed while it's crawling, if I give it full throttle and let off, sometimes it'll continue to go forward and kind of come to a slow roll. And sometimes if I let off too fast, see, there we go. That's weird. It's like if I let off fast, I don't know. Sorry guys, we're wasting time here. But there is something kind of goofy going on with that kind of fake slow roll, fake coasting, because the reason you can't really, and it might have something to do with the fact that we have worm gears versus ring and pinion. If it were ring and pinion, it may act a little better. The worm gears have a lot of resistance, and they automatically have drag brake basically built in. When you let off, it's like full drag brake, and they just kind of want to stop. They don't free wheel, unless you have really high ratio in there, or ring and pinions. Both crawlers, you don't really want a free wheel, so it's fine. They kind of, I think what they've done is because a lot of the guys run monster trucks using these axles, which is not ideal if you're going fast, because when you let off, the ring and pinion or the worm gear just wants to stop the truck and you'll flip. So what they've implemented is some sort of fake, there you go. It's like a fake freewheel. It's not even doing it every time, which is very frustrating. There you go. There you go. And it's kind of like you have to let off the throttle in this kind of smooth but fast motion. Not sure what which setting it is, but drag brake is probably best used when you're running reverse with brake on a traditional, ring and pinion style car. Like one of these guys, right? Drag brake slows you down when you let off the throttle without giving it actual brake. And then power field of control, that has to do with giving it more power as you're having resistance. So when you're climbing over rocks, it helps maintain a consistent RPM. So we max that out at 30. You're probably not going to see much here because it's upside down. You have to have resistance and it's got to be crawling. But that's what the FOC is. It's a very cool feature. And I'm not sure what neutral forward is. I think that's when you're letting off, how much power it continues to have. You can't hear it change. And that might have something to do with the what's kind of like freewheeling forward. That might be the neutral forward. The setting also seems to be how far away the throttle needs to be away from your neutral point before input is actually received. Some transmitters are less accurate than others, so changing this value might help if your truck seems to want to move while the controller is not being touched or isn't moving when you give it throttle. All right, so we're just going to leave that on normal. Now, punch has to do with getting extra power. It's like kind of like a dual zone on a joystick if you play games. It's basically your low end. Did stuff just disappear? Or we just disconnected? There we go. So having a low, that's weird. It just keeps disconnecting. All right. So having a high punch means that when you have just a little bit of throttle, you'll go from low. See, we're spinning right now. You can't really see, but we're spinning to having a lot of punch, right? See that jump? That's your punch. And if I turn that down, you can hear the motor slow, right? And that's how much punch it gets when it hits that break point or that second zone, right? So if you have it at 1, you basically have no punch. It's just going to be a smooth curve from 0 all the way up. No real huge jump in RPM. But if we put it all the way up to 10, you'll see a huge jump. We'll go real slow. We're spinning, and then we'll give it a little more, and then jump. Okay, so that's, people use that to kind of get over rocks. Like if you need that extra oomph to get over rocks, it'll kind of just pop it into that higher speed. Now you get that same thing just by slamming the throttle, right? So if you're going slow, you're going real slow, and you just need to get over rocks, you can just slam the throttle and it'll go. But punch kind of just does it instantaneously. Neutral brake. This might also have something to do with this. Oh, see, yeah, now it's doing it almost every time. I also read that this is how aggressive the brake is at slowing the vehicle down when the throttle is returned to 0. If we turn it down. Yeah, I don't know. Some of that freewheeling, imitation freewheeling seems kind of goofy. It doesn't seem to work perfect every time. There you go. And I'm not sure how neutral brake affects that. And that might have to do with if you have forward, brake, reverse. Low speed. So this is at what point does that punch kick in. So right now the motor's actually spinning, and you can see how much throttle I'm giving it, right? Tons of throttle. And it actually is never going to hit that. Oh, it did. That punch is actually at the very end there. So this is kind of adjusting the range of your dual zone. So if your first zone is slow and your second zone is fast, this kind of adjusts it. So if you think of this as like your center spot where the zone changes, and this is high speed and this is low speed, right now we basically have like this, where it's got all this low speed, and then it jumps here before we get a little bit of high speed, right? All this low speed, and then right at the end, it jumps. If we lower that percentage, we basically slide it like this, so now we have less low speed and all this range for high speed. So we have less low speed, just this little tiny bit of low speed, and then it'll jump. Now, you have to have our punch up to see it really, but that's this, right? And if we crank this up, you'll see that change. So that's how those interact, your punch and your low speed. Your punch is how fast it goes when it jumps. When your throttle hits there and it jumps, how fast does it go? And then your low speed is at what point in the trigger rotation does it go. And we like to have it so that it's just a smooth the whole way. So we turn our punch all the way down, our low speed all the way down, and we just have this smooth transition from slow all the way up. Okay, so that's the rundown. I know there's a lot there, but yeah. This is where you adjust your throttle curve. I wish they showed the line here when you were doing it. That would be super nice, but you can basically adjust this so that you pull your curve out, and this is basically as you're throttling it where the power is going. Basically how much power you have versus how much throttle, rotation you have. And we like this pretty smooth as well, so we'll probably do something like that. And then you can set the same for both, so it'll just automatically do both. If you want to change reverse, you can just switch over to here and change reverse. Okay? And again, you can see that here. So this is our 0. There's that curve we just set up, 10, 25, 35, 100. And this works sort of like you could set this up to work like your punch as well if you wanted it to jump way up. When you hit 30, when you go from 50% throttle, your 60% can just jump you way up, and then it can kind of have another curve here. So you can set kind of dual zones there as well. But that's the basic rundown. Again, the important things are make sure you calibrate, understanding what reverse and forward reverse, reverse with brake, and forward with brake are, making sure you can change your rotation, understanding your max forward and max reverse here. And then, like I said, this brake stuff, I'm pretty sure it mostly only works with forward and reverse with brake, and then our power field of control. Like I said, we like to have that max. It kind of really helps push it when you're trying to helps keep it smooth while you're pushing it over different terrain and hitting, it's got to build up extra torque. It just kind of helps keep it smooth so you're not just like popping over things. Yeah. I hope that helped you guys. If you have any questions, be sure to post them in the comments below. If I missed something or you know something that I messed up, make sure you tell us in the comments below, and I will pin it if it's good enough information. And yeah, make sure you like and subscribe and share and hit that notification bell, and then comment down below, Furitek rules. Also, if you don't like this video, hit that dislike, that thumbs down, hit that thumbs down button twice just to show us how much you do not like this video. 2 times.